Access the microphone. Okay, that should be going. All right, projector up, and we'll talk through some quiz. Guys getting excited for GDC? It's a special time of year every year. It's next week, I think, right? Yeah. If you can go, you should go. Definitely. It's like our Christmas in the game industry. It's like highly recommended. How many of you guys have been to GDC? Okay. E3? GDC is the one you want. Trust me. I've been to GDC a bunch of times. Went to E3 for the first time a couple years ago. It's okay, but it's mainly all marketing. So as people that make games, in addition to play them, you want to go to GDC. So I think the school has some passes, maybe. I don't know the details, but definitely look into that. Because if you can get even just the expo, it's really, really worth it. I think expo floor passes are pretty inexpensive, especially for students. So highly recommended. Okay, so last week's quiz. So first off, what's the correct way to check to see if both today is Friday and everything is awesome? Hopefully, I hope everybody feels this way every time we meet. So first off, we can just discard C and D, because those both have pipes, right? So pipes are logical OR of some kind, or I should say they're OR of some kind. So we're asking for an AND relationship, so C and D are both wrong in this case. So that leaves us with A and B. So both A and B have the ampersand, meaning that they're using some sort of AND relationship, but with the difference that A is bitwise AND, because it just has one ampersand. So B is what we're looking for in this case. It's logical AND. Now I should say that if I just saw this code, if like a teammate had written it, and I was encountering this for the first time, I would assume that today is Friday and everything is awesome are Booleans, because it's generally good style to name your Boolean values kind of like that, right? So if you have something that is a Boolean, it should be named in such a way that it's kind of like a little sentence that evaluates to true, right? So you should almost be able to uncamel case it and put is true at the end and have a valid sentence, right? Today is Friday is true, right? It's kind of conceptually what's going on there. Anyway, so if this was the case and they were both Booleans, what we would end up with is 1 bitwise and 1, which gives us 1. So in the specific case of if they were both Booleans, this would work, but it's not what you want to do. Because notice, like, I'm making a lot of assumptions there. If it happened to be a Boolean, do I know it's a Boolean for certain? Not necessarily. This might not be code I wrote, right? And it's a good recipe for getting sort of unexpected behavior, right? Because the minute that today's Friday might assume a value of 4, and everything is awesome might assume a value of, let's say things are really awesome, and everything is awesome assumes a value of 64, right? So what's 64 and bitwise and 4? It's true, because they're both powers of 2, right? So we have two numbers that are both individually powers of 2. You bitwise and them together, what do you get? Kind of guaranteed. Well, so any number that is itself a power of 2 will have exactly 1 bit on, and everything else will be off, right? So 1 is just 0, 0, 0, 0, 0, 1. 2 is 6 zeros, a 1, and then a 0, right? So anyway, so 4 bitwise and 64 would be 0, right? Whereas 4 logical and 64 would be true, because they're both non-zero values. So kind of lengthy, but B is the one we want. We want a logical and. Okay, so 2, this is pretty straightforward. Nothing really tricky here. It's just you just have to remember it, right? This is less about high concept, and this is more just memorization, right? It's always a blend of both. So, sorry, 2. Function signature is all of those things, right? So you have to have return type, function name, and any and all inputs. And that's something that actually applies to programming in general. So it's good to kind of think in terms of function signature and what defines the function being those 3 things. What it takes in, what it spits out, and what its name is, right? So, okay, floating point error. So this is a little bit tricky, right? But I really want to drill this into you guys a little bit because it's super important for your career as programmers. So yeah, you just have to learn early that there's nothing you can really do about floating point error. It will always, always, always be there. I can't really conceive of a way in which it wouldn't be there, right? So it's fundamentally caused by the fact that computers are finite machines, and some of the numbers we want to represent aren't finite. Some of the numbers we use a lot, like pi, right? Not finite. Even just dividing 2 by 3, right? You get 0.666666 going on forever, not finite. So you get 0.666666, and then at some point you get a 7 there, usually. So no real way around it. You just have to kind of program around it, right? You have to be aware that it's there. Easy to deal with if you know that it's there, but it's always going to be there. So I linked to a website you guys should take a look at if you want to know more. It looks like a pretty good sort of, starts out pretty simple, but goes deep if you want to go deep on floating point error and how floats are represented on computers and all that kind of good stuff, right? Okay, 4. So in this little setup, what I asked you guys for was I've got a floating point value, float, and I'm setting it equal to a made-up function. Now, so what goes on inside doesn't matter, but I named it, and please never do this. Don't actually have functions named that long, right? Unless you're writing a quiz for your students and you want to make it abundantly clear what something is doing, right? So I've got some very involved mathematical calculation, right, that theoretically could spit out 4, or something like 4, right? But it's a float. So that means that what should be 4, what would absolutely be 4, exactly 4, if we were doing it with pen and paper, or in our heads or whatever, if we're doing it in pure math, we would get 4, might actually end up being 3.9999999 or 4.000001, right? So if we do the sort of typical thing that we generally do for equality, we just have my float equals 4, that might work, but it's really risky. And the danger there is it would work probably when you were doing your testing, when you were implementing it, and then that part of the code base would go off to QA, and you get really weird errors where things that absolutely would be 4, because I guarantee this is what happens, right? With these kind of issues. You look through the logic, in this function, for example, and you look over and over and over, and for the life of you, everything there is saying that this will give you 4 as a result. And you'll keep thinking, well, I must have the math wrong, right? I got to double check, triple check the math. And the math will be totally right. Except it'll be a tiny bit off. And what should happen here won't, right? So I saw a lot of people do this, which is totally fine. So you can say if my float is greater than something a little bit less than 4, and it's less than something a little bit more than 4. That is totally fine and valid. I wouldn't personally do it that way, however, because what's going on here is, let's say our target changes from 4 to 6. So if that happens, I have to remember that this now needs to be 5.999, and this needs to be 6.001. So I have to change it in 2 places. And whenever possible, if you can make something so a change requires a change in 1 part of your code rather than 2 or more parts of your code, that's almost always going to be a good thing to do. So the way I recommend doing it, although just, again, this would work fine, but I recommend doing this, using subtracting, taking the difference, doesn't matter which way you go, between the thing you're testing and the target value, then taking the absolute value of that, because we don't know if it's going to be a little bit greater or a little bit less, right? So we take absolute value, and then checking that to see if it's less than some small amount. Where you can kind of, use this as an adjustment to say, how big of a range around 4 is okay. And then if I want to change this to 6, I change it in 1 place. If this was really important, I probably want to take this completely out of that if and do what with it? What would if this was like a really a common number that I was checking a lot, what might I want to do? Make it a const, exactly. So I'd probably want to break it out and make it a const. There are other options that we'll talk about, like I can make it a static member of a class. I like doing that a lot, but yeah, constant would probably be a good way to go. Cool. So questions about last week's quiz? Oh, thanks. All right. Okay, so what I want to talk about today is last week we talked about arrays, right? And we saw that there were definitely some rough edges to standard arrays. So I said quite a few times last week that there are other ways, there are nicer ways to work with list-like objects in C++. So I really wanted to take the time last week and look at just what a raw native array looks like, because it brings up a lot of things you guys need to know about. However, that doesn't mean that in your actual work lives as programmers, that's necessarily what you're going to use. So, so I've shared my screen, the meeting ID is up here. So what I want to start talking about today is something called the standard template library. So C++ is in some way, it's a very hard language in a lot of ways, and it's very powerful, right? But the thing that is maybe less obvious but very important to realize about C++ is it's really a pretty low-level language, right? So if you're just using the raw C++ language, you have to do a lot of sort of mental legwork, right? So you don't want to do that, right? A good programmer is a lazy programmer. It's one of my good friends, one of the best engineers I know, is fond of saying that. Which is not to say that good programmers don't do work. It's just that you want to do the least amount of work, right? You want to be as efficient as possible. So generally what you want to do is you want to use libraries that help you work faster, better, and more efficiently, right? So everybody does that. That is a huge part of being a working software engineer, is you use libraries, right? So we've seen at least one so far, the string library. So I'm going to talk a little bit about that today later, right? A couple things about it because we just kind of use them. And the reason for that, the reason I haven't really talked about it much, is the alternative to work with text in just native C++ is you have to use a character array. So if you're dealing with strings, what we've been calling strings, and just straight up C or C++ without anything added, you have to use character arrays. And they're fine, but a little more involved. And they would be missing things that you guys would like, right? So we've already been using those. Today what I want to talk about a little bit is, first off, what the STL, or the standard template library is, what templating is, and talk about two of the most useful, I would say, libraries in the STL, the array library and the vector library. So both arrays and vectors, at least in this context, are list-like objects. So we'll talk about that. So, okay, so standard template library. What it is it's standard, right? It's part of standard, right? So we've been using namespace standard. We're going to talk about standard : array. And later today, we're going to talk about standard : vector, right? So that's where the standard comes from. Library is pretty simple, right? It's a library, right? Now the template, though, is where it gets really cool and a little bit strange, right? So let me fire up a source file. I'll make an empty project. I'll call it week 6. And I'll make a new source. C++ file. Okay, so I'm going to include IOStream, as we generally do. I'm going to, using namespace standard, int main turn 0. I should also say before we get into things that STL is a huge host of concepts, right? There's no way we're going to even scratch the surface, really, of exploring it fully in this class. But I do want to talk about at least a couple of things, because as you guys work on your projects for this class, and if you do any sort of like programming challenges, if you go on HackerRank, or you're on like Daily Programmer subreddit, or any of those things that I linked to on the class site, these libraries are going to help you a lot, right? So I would feel a little bit bad if you guys continued for the whole rest of the semester using like native arrays and not using standard array or like standard vector, because it's much nicer. And it's also much nicer in a way that if you were actually working at a game company writing C++ code, you would absolutely be doing that. It would actually be, your boss would probably yell at you if you didn't. And the reason for that is the standard STL is generally, the implementation is really hammered on by quite a lot of people, and they can generally be trusted to be I want to say safe and fast, and I was saying fast or something. Anyway, so safe and fast and efficient, right? So now it's not that you guys aren't capable of writing something that's safe and fast and efficient, right? But why would you want to when you've got off-the-shelf solutions that have been hammered on by hundreds, if not, well, thousands, really, of people? So, no matter how smart one person is, they're never as smart as 1,000 people, right? It's like why Linux doesn't get viruses, usually. Okay, so I'm going to include array. So now I can use standard or std : array, right? Now, of course, I've got using namespace standard, so I'm not going to need the std : But I can make a standard array. So let's look at how that works, right? I'm just going to type it, and then we're going to be able to talk about what templating means, which is a really cool thing and very, very powerful. So what I'm going to say is array Okay, so let's talk about this. So first off, we see array, right? So if we kind of like squint a little bit and just ignore this section with the inside the less than or greater than, right? It's not too different so far from what we've done in the past to declare a variable of some type, right? So, we say int, my int, float, my float, etc., right? So, high level, I'm saying array, my array. Here's where it gets cool, though. So what the STL libraries are about, what the templating is about, is they're classes that have been implemented in such a way that they can use multiple types of data. So when I make a std : array, I have to say two things. First off, I still have to say how big it is, because these arrays are also fixed size. Very important. So there's going to be some things we get by going this route. The two big ones we'll always be able to know how big the array is, even if we pass it around a function. And we'll also get, it'll be very easy to sort the array, in addition to some other things that can happen. But an array is still a fixed size. So just know that. So I have to say how big it is, and I also have to say what type of data it's going to contain. This is where it gets really cool. So array gives us some functionality. For example, we can call size, right? And we can know how many elements are in there. But what's cool about it is it's implemented in such a way that we can have an int array, we can have a float array, we can have a double array, we can have an ogre pointer array, right? And all of those things we can just throw at array, this standard : array, the STL library array. So that's where we get the real power, right? So and pretty much all the libraries in STL work that way, right? So, and a little bit later today, we're going to look at vectors, which are similar to arrays, but they can change size. And it's the same thing. We can say, I want a vector that's primed to hold ints, or I want a vector that's primed to hold floats, or ogres, or whatever, right? So, super powerful. So just to kind of like talk about that a little bit, I'm going to show you how you can define a function that uses templating. Now, big disclaimer in what I'm about to show you. You can use it. I don't recommend that you do yet. Right, so I want to walk through it just to show you how templating works a little bit. But I don't recommend yet actually writing functions using templating. But it's kind of a weird concept, so I want us all to see it in action in sort of the smallest possible case. Right? So what I'm going to do is, let's say we want a function that can add two things, right? Now, it makes sense to add two ints, right? It makes sense to add two floats. We could even say that it makes sense to add two strings, because it happens that the string library defines plus to be string concatenation, right? So foo plus bar is foo bar, right? It's not like, because it's otherwise it could, it could look at the ASCII values and add them together and then do something crazy. But plus for strings has been defined in a nice way that makes sense. But and you still use the plus sign. So anyway, so let's say I want one function to do all of that. So here's what I can do. So let's say I wanted to add ints, right? Well, that's pretty easy, right? I can say int add ints, int a, int b, right? And I can say return a plus b. And let's say I want to add floats. I can say float, add floats, whoops, float a, float b. And I can say return a plus b. And I can't do this without string, so I'm going to... Would be pretty cool if we could include sting. I don't know what he'd do to our code, but... All right, so I can say string, add string, string A, string B. Okay, so let's look at those. So again, this is a toy example, right? But in all cases, it so happens that if I have two ints, addition is nicely defined for two ints, right? Adding two numbers, easy. Addition is also nicely defined for two floats. Addition is also nicely defined for two strings. Now, the reason for that is not that it makes mathematical sense to add letters. The reason for that is that the implementation of string includes defining an add method. So one of the things that you'll see as you go farther into C++ is once we define classes, you can not only can you write your own functions, right? So with my ogre, I keep going back to, my ogre class might have a eat function, right? Or like an attack function, right? But you can also you can define, you can overload operators. So I could say adding two ogres means this. And I could say ogre A plus ogre B. And maybe that's how like the population simulation works. I don't know. But so you can do stuff like that, which is one of the cool things about C++. So that's been done for string, which is why we can say A plus B, right? Okay, so we've got three functions. All of these would work fine, right? But it's a lot of repetitive code. Right? So what we can do is we can make one function that we're going to call a template function. And again, take this as sort of like a behind-the-scenes enrichment kind of thing. That is really what I want to get out of is mainly just what templating is. So when we use STL libraries, it makes sense. But for the sake of showing you, because it is a kind of cool thing in its own right, where are my notes? I can do this. And hey, get this. I got too many papers today. There we go. Okay, so that's a whole bunch of syntax of code, right? So first off, what's going on is I'm using the template keyword to identify this function as a template. Then what I'm doing is, so what I'm setting this up to do is to take more than one type of variable, right? So what I'm doing here is I'm saying class type. So in this case, type could be anything I want it to be. So I could call it, my type. It's a little bit like how we work with variables and function declarations. So I could say something like my type, and then change this to my type my type. Okay, so what's going on is we're saying we're going to take in this class of whatever it is, right? And then we're saying that this function is going to take in two things of that type and return something else that's the same type. So we could say, we're going to set this to int, right? We're going to throw two ints at it. And this function would work fine with two ints. So, it'll take it, this would be equivalent to int. So we say, okay, we're taking in two ints and we're spitting out an int. And what we're going to do inside is add these things, right? So should be able to just compile this and have it work. Show you guys I'm not lying. All right, so I'm going to yeah.
Are we supposed to add the parentheses for the return in the template one or no?
Oh, good eye. Yeah, it doesn't actually matter. So good looking out though. So things like that do matter sometimes, right? I would prefer it's a stylistic thing, and I would argue that this is a nicer way to do it. So it was an oversight on my part. No, thanks for asking. I'm glad you pointed it out because I do think that what I had a minute ago was a little sloppy, honestly, just stylistically. Right? So, yeah. So we'll add ints, and I'll say add 2, 2 comma 3, inline, and then I'll say adding floats, add to 2.3, 5.7. And let me just input. Let's. Oh. All right, so I just happen to choose floats that give us exactly 8. So let me fix that so it's a little less. 5.4, let's say. Okay, so now we see adding ints 5, adding floats 7.7. But in both cases, I'm saying add 2, right? So for strings, though, it gets a little complicated in that if I just do this, if I say adding strings, add to we should get an error. Oh, I should actually quit the. So we get an error, right? So we see, let's see. Well, that's not a very. Well, we see error. So here's the important thing. Cannot add 2 pointers. So what's going on here is, so this is another way in which, it's one of C++'s sharp edges, right? So if you're used to other languages, a string, this is a perfectly valid string, right? But that's not how C++ sees it. So if we make a string and we set it equal to quote FOO quote, that's fine. However, if we just have quote FOO quote, what the compiler is going to think that is an array of characters. So that's what it defaults to. All right, so I'm not actually passing in 2 strings here. I'm passing in 2 arrays of characters. So we can deal with that. And just to prove to you guys that it still works and we can add 2 strings this way, I'm going to say string A equals foo, and string B equals bar. Now if I do that, we'll see it working for everything. So we get 5, 7.7, and foobar. So we have one function that does 3 things, right? So it can actually do more things too. If we later on, implement our ogre class, as long as we implement the plus operator for that class, we'd be able to throw 2 ogres at add2, and it would work fine. So the key thing to understand about templating is, again, don't worry too much about this, and I don't recommend actually using this in your code yet. It's a little bit like what we talked about with switched case statements. They're fun, they're great. Those are great to use, but how you can leave out the break and have multiple clauses execute. That can be a good thing to do, but I don't recommend doing it yet until you guys have a little more experience. So same thing with actually making templated functions. Not really recommend it just yet, but I do want you guys to use STL, and that requires understanding how templating works. And the central thing about templating is we're essentially passing in not only an actual value, right? So up here in our just vanilla function, right, our just normal function, we're passing in two values, right? We have this string A and string B, right? But with templating, there's this additional concept of passing in a type. So not only are we saying, here's the specific integer, right, the two specific integers I want you to add, I also want you to get the type from that. So it's kind of meta, right? It's like, it's not just one function, it's a host of functions. It's theoretically an infinite number of functions that are all slightly different because they're doing different stuff, right? Adding a string is a very different operation than adding an int. And even adding an int and a float, or adding two ints and adding two floats, is technically a very different operation too. So we're invoking one of those three with the same function. Questions? Hit it. Sure. So what we're doing here, right, is I wanted to name it my type to make it a little more obvious that it's a word I chose, right? So the keywords here are template and class. So this little bit of syntax here with the less than, class, blah, greater than, is saying we're going to take in the type of the variables that get passed, and I'm going to make use of that, right? So it's kind of like, up here we're saying A, right, is equivalent to saying whatever the first argument was. This is kind of like saying whatever the type passed in was. Sort of. You can have multiple types, and that gets more complicated. But the key thing is we've got this one. It's kind of like we're making this. I don't want to call it a variable because it's sort of like a meta variable. It's not actually holding data, but it's specifying the type of data we're working with. So it's kind of like I'm saying whatever class we're using, and class just means in this context, a type of object. Ints aren't really a class in C++, but they're a type of thing, right? And most of the stuff you end up, it's very quick. When you're working on a project at sufficient scale, you'll very quickly, you'll almost never be working with ints and floats directly, as far as what gets passed around. It'll be, ogres and level data and higher level classes. Right? So, excuse me. So what's going on is we're saying whatever type we've got, whatever class we've got, I'm going to refer to that as my type. And once I've got sort of that handle, a way to refer to it, I can say that that's the type we're going to, and then from here out, right, if we just ignore this, right, notice it looks just like a normal function declaration, except what's a my type, right? If this was actually replaced with string, we'd have exactly what I've got here, right? If I just kind of cover that up, and we think of this being string, right? We have string output, so our return type, our function name, and then whatever inputs we have. In this case, two of the same type, right? So from here over, it's pretty normal, except my type actually isn't a class type. There's nothing that has defined what my type is as its own class. What it is instead is I'm saying whatever class we've got, let's refer to that as my type. And then I'm going to return one of those, and I'm going to take in two. Yeah, and say.
That way it's kind of like, as opposed to changing something to be a type, it's more like a sticky note. Like I would use full right.
Yeah.
Kind of makes it off, like you use something else.
Well, sort of, yeah. So it's more like, think of this as almost like a factory, right? So think of this as a tool, right? So a normal function is kind of like a tool, right? Think of it as a specific sized wrench, maybe. Think of this as the CAD file that makes all possible wrenches, right? So if I need a wrench, if I'm going to tighten or loosen a bolt, right? For that to work, I need a wrench of the right size, right? But all wrenches are kind of the same thing if you just ignore the size, right? You get, they have like this hexagonal cavity, right, that fits into a bolt, or a bolt fits into. So this is like, specifically having a 3/16 of an inch wrench. This is kind of like saying, whatever size we've got at the moment, give me a wrench of exactly that size. So, and the reason I wanted to phrase it that way is because within the context of using a templated function, it is always specific. Like, what we can't do is I can't say add 2 with one int and a float. I can't do that, at least not as this is written. So it's not just totally willy-nilly. It's still very, it has to be exactly one type, at least as I've got it written. But it can be any one type. So the only way that this would break down is so ways that this would break down, right? There's a few. So if I put in mixed types, that wouldn't work. Or if the type I was using didn't have a plus operator defined. So it just so happens that these three all have that, right? But okay. Questions? This is a little subtle and it's a little deep, right? So again, don't worry too much about actually making use of this directly. But it's just working with C++ and not using STL libraries is just so painful. And I don't want you guys to have to deal with that, right? So, and I want you guys to have a good grasp on what the templating is doing, right? So, file that in the back of your head. Maybe use it later, maybe you don't. But templating is really cool because it lets us do things like define this array, right? So now we've got an array, and deep in the implementation of standard array, everything is templated nicely like that, right? So I know we haven't really talked about object-oriented programming yet, but just to keep kind of touching on these concepts, super high level, you define a new type of a thing, right? So what we're getting when we import a library is we're basically getting new classes. And a class, in that context, is a thing, right? It's like a noun, is a good way to think about it. So when you start writing your own classes, a good way to start thinking about them is ask yourself for your project, what are the nouns? So, that's why I keep using ogre, right? Because if I'm making a fantasy game, there's probably going to be ogres, right? There's going to be things like potions and swords and stuff. So that's what we get in the library, right? So in that library that we included, there are classes and functions defined, right? And all that stuff is implemented in such a way that it's templated, which is really cool because it lets us do stuff like that. And use exactly the same functions on no matter what type of thing we're filling it up with. All right, so this